Still many are joining. Okay, let there be a container. Water equivalent of calorimeter, I'll write 2 gram. This is the water equivalent of calorimeter. So initially it contains ice. I said say minus 10 degrees Celsius. So what is the amount of ice? Let it be 10 gram. For this, I'm going to add water, 20 gram of water at say like a 10 degrees Celsius. Now what should happen to this? What will be the, if find the, so 20 grams of water at 10 degrees Celsius. I'll write to 12, so we'll get confused, minus 10 plus 10. At 12 degrees Celsius is added to 10 grams of ice at minus 10 degrees Celsius kept in a calorimeter of water equivalent 2 gram. Find the final temperature of mixture. Okay, now we'll do one thing. So what do you expect? The final temperature should be less than 12 and should be greater than minus 10, should be in between. So in between any value. So for that, I think we know formula. Directly you can't say that, so I'll use that formula. I'll apply it. That one. So we know formula, we have to carefully analyze here. So first what we do is like, for the whole ice to melt, what is the heat required? First from minus 10 to become 0, what is the heat required for ice? Q1 I'll call it. So what is Q1? Mass of ice. So latent heat of, specific heat of ice is how much? 0.5 calorie per gram per degree Celsius. Specific heat of water, 1 calorie. Okay, these are the data. What I'll be, and latent heat of fusion is 80 calorie per gram. Okay, no. For the temperature of ice to increase from minus 10 to 0, what is the amount of heat required? So mass of ice, specific heat of ice, 0 minus of minus 10. Please do understand, I need not to write all the sentences. So what is given? Heat required to rise temperature of ice. This is the first problem, I'll write it. Heat required to rise temperature of ice. So what is mass of ice? 10. Specific heat of ice, and this bracket is 10. So and that 50 calories of heat is needed. Okay, after this, even the calorimeter also, what happens is temperature from minus 10 should become 0, no? Heat required to rise temperature of calorimeter. Let me call that as Q2 or QC. I'll write it. It'll be easy for you. So, but we don't know mass of calorimeter, specific heat of calorimeter. Tell me, what shall I do? Anybody wants to reply? We don't know these two terms, no? What
Sir,
shall
water
I?
equivalent is given.
Water equivalent is given, that you're going to write here. Fine. Huh? There's a trick, finish over. So this will be 10. So 20 calories is needed for calorimeter. So how much is needed? 70 calorimeter. Who should provide this much of heat? The water. If the temperature of water falls from 12 to 0 degrees Celsius, tell me how much of heat will be available. I think roughly we can say no specific heat of water is 1. So 20 into 12, 240 calories. But how much is needed? 70 calories. So remaining heat, what will happen? Remaining heat, what will happen? So here heat released when temperature of water decreases, changes from 10 degrees Celsius to 0 degrees Celsius. Let's assume. So how much of heat released? So I'll call this as Q naught or QW. So what is QW? Mass of water, specific heat of water, 10 minus 0. Mass of water, 20. 12, no, this is 12 minus 0. So 20 into 1 into 12. 240 calories is available. Tell me what will happen here. Is it all ice will melt? We know. So heat required for all ice to melt. Let's cross check. We don't know. The whole ice will melt. A part of ice will melt. We don't know that one. So separately we should calculate here. Heat required. So this is heat required for all ice to melt. I'll call Q dash. This is how much mass of ice into latent heat of fusion. Mass of ice is how much? 10. Latent heat of fusion how much? 80. 800 calories is needed. But what actually is available? 240. In that 240 calories, 70 calories is used to bring the temperature from minus 10 to 0. So in 240, if you take out 70, how much will be left over? 170 calories is left over. So that 170 calories, what will happen? So that 170 calories is utilized to melt the ice. So is it all ice will melt? The answer is no. To melt, for all ice to melt, how much of heat is needed? 800 calories are needed. For all ice to melt, 800 calories are needed. But how much of heat is available now? Only if you from 240 you remove 70, 170 is out. In that 170 calories of heat weapon is utilized to melt the ice. Agree this? So I think, sir, how do I come to know? This is what you should verify things here. So this part is something. So this QW is what? Less than Q dash. So therefore the whole ice will not melt. As QW, Q dash, whole ice will not melt. Now this statement is something very important. Whole ice will not melt. So how much of ice will melt? How to say that one? So let's see that this QW. I think better. I'll make it everything visible here. Okay, now you can see this. Let's get into the QW should be equal to amount of heat requires to rise the temperature of ice from minus 10 to 0 plus amount of heat required to increase the temperature of calorimeter from minus 10 to 0 plus amount of like a required for the ice to melt. For the ice to melt, I don't know what amount of ice will melt. I'll call that as M. Okay, clear this one, M, and let this be LF. So QW, we know it. How much? 240. Q1, 50. This is how much? 20. Plus, we don't know the amount of ice that will melt. If you QT, I'll write it. Total, it will symbol, let it be like this. Okay, here I'll put it M dash symbol. Okay, this will be LF. What is LF? 80. Anybody value of M dash?
2.125.
The amount of ice melts M dash is equal to how much you'll get? 240 minus 50 minus 20 by 80. 2.125. So 2.125 gram of ice will melt. The remaining amount of ice will be there in the container like that only. So what is the temperature of mixture? Anybody?
0.
Zero. It should be zero. So students, shall I tell you one thing? Almost maximum students, they want some formula. They want some formula and they want to substitute and they want answer. Tell me, I think you are really supposed to think, no? What will happen? So this particular thing, the blue color, this is the idea which you have to search. This is an idea to be verified. This will help us to decide what will happen to the problem. So what you have to make a guess, let all ice will melt. Is it that much of heat is needed or not? Okay, that much of it is not needed. Then all ice will not melt. Able to understand? So now, therefore now what shall we write? So final content of the calorimeter. I'll put a small diagram. There will be water. There'll be water. So how much of water? In that, there'll be also some ice. So how much of water? For 10 gram, I should have 2.125. So 12 point, there's the water and there's the ice. How much of water? Water. And how much of ice will be? In the 10 gram of, so 20 gram, no? 20 means this will be 22 will become. For 10 gram, if you remove 2.125, anybody value 7 point?
07.
07. So 125 is there, no?
875.
It cannot be 8, no?
7.875.
7.85.
75.
875. Okay, this much of ice. And what is the temperature? 0 degrees Celsius. So final, so what are the final temperature? Final temperature of calorimeter is 0 degrees. Final content. So how much? 22.125 grams of water and 7.875 grams of ice. Okay, now this is the way what happened. We have to fight with the situation. Nothing is there. So again, though you have a formula, straight away you cannot apply. You have to verify things. What can happen? Sir, how do I come to know ice will melt or not? I think there's a cross check. QC, QT from here. Okay, I'll take the next question. I'll scroll down. Huh?